In this lesson, we want to review systems of linear equations in 3 variables. All right, so in our last lesson, we reviewed how to solve a system of linear equations in 2 variables. We looked at the graphing technique, we looked at substitution, and we also looked at elimination. So this was nothing new for you. If you're in this course, you saw this in Algebra 1, you saw it again in Algebra 2. This is just to review something that we need to understand as we kind of move forward in this chapter and we start looking at matrices. So kind of the next step or the next piece of this is to review system of linear equations in 3 variables. So this is also something you should have seen probably in Algebra 1, if not definitely in Algebra 2. So let's recall when we work with a linear equation in 3 variables, we typically see the variables x, y, and z, right? With 2 variables, you see x and y. With 3, you see x, y, and z. So something like, let's say 2x, we could say plus 3y, then minus 4z. Let's say this is equal to 12. So notice how you have, again, 3 variables. You have this x, you have this y, and you have this z, okay? So before, when we worked with a linear equation in 2 variables, our solution was given as an ordered pair, right? You had x comma y. Well, now, because you have x, y, and z, it's given as an ordered triple. So this guy would be x comma y comma z, okay? Now, you can generate as many ordered triples as you want, right? There's an infinite number of ordered triples or kind of solutions for this type of equation, just like we saw for a linear equation in 2 variables, right? It's the same thing. When we looked at a linear equation in 2 variables, we could pick something for x and solve for y, or we could pick something for y and solve for x. Here, I would have to pick something for 2 of the 3 variables, and I could solve for that third unknown. So as an example, let's just say I picked the number 1, and let's just say I picked the number 2, okay? So I'm choosing 1 for x, so this is going to be a 1, and I'm choosing a 2 for y, so this is going to be a 2, and I don't know what z is. I'm going to plug in here, I'm going to figure that out, okay? So that's going to give me an ordered triple, or one solution for this equation. So 2 times 1 would be 2, then plus, 3 times 2 would be 6, then minus, we have 4 times z, and this equals 12. So 2 plus 6 is 8. I'm just going to erase that real quick. And I know that to solve this, it's very simple. I would subtract 8 away from each side of the equation. I'm just going to erase this from over here. 12 minus 8 is 4, okay? And so I can quickly divide both sides by negative 4, and I'm going to find that z is equal to negative 1. Okay, so this is a negative 1 here. So we're saying that if x is 1 and y is 2, then z is going to be negative 1. So this is an ordered triple, or one solution, okay, amongst an infinite number of them for this equation, 2x plus 3y minus 4z equals 12. Now, suppose we take 3 of these equations and we put them together and we make ourselves a system. How can we get a solution for this? Are we going to use graphing? Are we going to use substitution? Are we going to use elimination? Well, graphing is pretty much out the window with this. It wasn't very practical when we looked at a system with 2 variables, right? It is if you have integer solutions, right? But if you have something that's not an integer solution, it gets pretty hard, right? Or if you have really big or really small kind of answers, it also gets really hard. Well, for this one, you're not going to be graphing with a 2-dimensional plane. Now you need 3-dimensional graphing, so this is pretty much only going to happen on a computer. Now the other thing you could do is you could use substitution, okay? But it's very, very tedious. So typically in your textbook, you're not going to see substitution used. The fastest method is actually to use a matrix, but we haven't gotten to that yet. So what we're going to do is we're going to use kind of an extension of the elimination method, okay? So the way this works, we're going to take 2 of the equations and we're going to eliminate one of the variables. So we can choose to eliminate x, y, or z. It doesn't really matter. Then we're going to choose a different 2 equations. Okay, it has to be a different 2 equations. And we're going to eliminate the same variable. Okay, so once we've made that choice in the first step, we've got to stay consistent. So what this is going to do is it's going to give us a linear system in 2 variables. Once we have that, we can use substitution or elimination or really whatever we want because we're just working with 2 variables at that point. Okay, so it would be very, very simple. So to show you this in practice, we have 7x plus y plus 5z equals 27. I'm going to label this as equation 1. Then we have 4x plus 3y plus 5z equals 21. I'm going to label this as equation 2. And then we have 6x plus y plus 2z equals 9. I'm going to label this as equation 3. Okay, these numbers are just for reference sake. What I'm going to do is I'm going to start with equation 1 and 2, and I'm going to eliminate one of the variables. Okay, the easiest one to eliminate is going to be z, right? Because I have 5z and 5z. If I just multiply either equation 1 or equation 2 by a -1, I'll have opposite coefficients on the variable z. And so if I kind of add the left sides together and add the right sides together, on the left sides, when I add them together, z is going to drop out. Okay, so what I'm going to do is I'm going to keep 1 as it is, and I'm going to take 2, and I'm going to multiply both sides by -1. So let me copy equation 1 again. So 7x plus y plus 5z equals 27. Then for equation 2, I'm going to multiply it by -1. So everything's just going to have a change of sign. So instead of 4x, I'd have -4x. Instead of 3y, I'd have -3y. Instead of 5z, I'd have -5z. And this equals, instead of 21, I'd have -21. And again, this was equation 2. So let's label that so we can stay consistent. All right. So with elimination, you're going to add the two left sides, set this equal to the sum of the two right sides. And for this to work, you've got to have it in this format where you have ax plus by plus cz equals d. Okay, so you want all your variable terms on one side and you want the constant on the other. Okay, so that's how it's going to be set up. So that's already done for us, so we don't need to do any additional work. So when I sum, 7x plus -4x is going to be 3x. And then y plus -3y would be -2y. We know that these would cancel, and this would be equal to 27 plus -21, or 27 minus 21 would be 6. So this equation here that I've generated, I'm going to call this equation 4. So let me erase these two. I don't need this information anymore. And I'm just going to write this off to the side and say this is my equation 4. It's going to be 3x minus 2y is equal to 6. Okay, now I used equation 1, let me mark this, and equation 2. Okay, so now I can't use equation 1 and 2 again. I can use equation 1 and 3, or I can use equation 2 and 3. But the key thing is I've got to eliminate the variable z again. Okay, so let's just go with 2 and 3. So let me erase these check marks, and I'm just going to put a mark here and here to remind you that we're working with 2 and 3. Okay, so I need to eliminate the variable z. This guy is a 5, this guy is a 2. So what I can do is take the LCM of 5 and 2, which is 10. So for this guy, equation 2, I'm going to multiply both sides by 2. That's going to make the coefficient of z a positive 10. So I'm going to say that 2 times 4x is 8x, and then plus 3y times 2 would be 6y, and then plus 5z times 2 would be 10z. This equals 21 times 2 is going to be 42. So again, this is equation 2, and I'm not going to label this here because we're going to get rid of it in a second. Then for equation 3, I need to multiply this guy right here by a -5, right? Because I want to end up with a -10 so that it will cancel with this guy right here. Okay, so I'm going to multiply both sides of the equation by -5. So 6x times -5 would be -30x. And then y times -5 would be -5y. And then 2z times -5 would be -10z. And this equals, if you had 9 times -5, you'd have -45. Okay, so let's add the left sides together. Set this equal to the sum of the right sides. So 8x minus 30x is going to give me -22x. 6y minus 5y is plus y. And then we know this is going to cancel. And this equals 42 minus 45 is -3. Okay, so let's erase this. We don't need this anymore. And let's drag this up here. And we'll call this equation 5. Okay, let me change the color here. So this is equation 4. So now, if I look at equation 4 and 5, this gives me a linear system in two variables now, right? Z is eliminated. So let's work with this now. We'll figure out the values for x and y, and then we can go back into either equation 1, 2, or 3, plug in for x and y, and find out the unknown z, okay? So for this one, it looks like it would be pretty easy to use substitution because the coefficient on y here is a 1, right? So I can solve this for y pretty easily. I can say that y is equal to, if I just add 22x to both sides of the equation, 22x minus 3. Okay, so then what I can do is I can take this guy right here and I can plug it in for y in this equation 4. Okay, so that's going to get plugged in right there. So what I'd have there is 3x minus 2 times, again, this quantity right here. This is being plugged in for y. So that is going to be 22x minus 3. Okay, let me change the color again. And then we have that it's equal to 6. So let me scroll down and get some room going. And we'll come back up. So for this guy, we have 3x, and then I'm going to distribute the negative 2 to each term. So that would be minus 44x, and then plus 6, and this equals 6. So I have 6 on each side of the equation, so I can just get rid of it. Right? If I subtracted 6 away from each side, this would just be a 0, and over here it would go away. So 3x minus 44x would be negative 41x. So negative 41x. And we know this equals 0 at this point, but let's just complete this. So divide both sides by negative 41, and we'll find that x is going to be equal to 0. Okay, so let's erase this, and let me scroll back up, and let me write this over here. So we've found already that x is equal to 0. Okay, so that's the first one. So I can plug in a 0 for x in either equation 4 or 5, find out the value for y. So let's use equation 4. 3 times 0 is 0. So I would have that negative 2y is equal to 6. Divide both sides by negative 2, and we'll get that y is equal to negative 3. So now I know y is equal to negative 3. Okay, so x is 0, and y is negative 3. Okay, so from here, I just have to figure out what z is. And to do that, I can plug into either equation 1, 2, or 3. Doesn't really matter. So let's just choose equation 1. So we would have 7 times 0, which is 0, plus you have y, which is negative 3, so negative 3, plus 5z equals 27. So let's add 3 to both sides of the equation. Let me scroll down for a minute. I'll come back up. So we know that this is going to cancel. 5z is equal to 27 plus 3 is 30. Divide both sides by 5, and we get that z is equal to 6. Okay, so let's erase all this, and let's scroll back up. And we'll say, again, z is equal to 6. So I would write my solution again as an ordered triple. So I would say it's the x value, which is 0, comma, the y value, which is negative 3, comma, the z value, which is 6. Now, I'll let you check this on your own. I've already checked it. I know it works. To check this, you're just going to plug in a 0 for each x, a negative 3 for each y, and a 6 for each z. And you want to verify that in each equation, that solution gives you a true statement. All right, let's take a look at another example. Now that we've kind of done one, we can go a little bit quicker for this one. So we have 2x plus 4y plus 5z equals 15. Let's call this equation 1. We have negative 6x plus y plus 4z equals negative 25. Let's call this equation 2. We have negative x minus 3y plus 3z equals negative 16. Let's call this equation 3. Okay, so again, I want to pick two equations. And with those two equations, I want to eliminate one of the variables. Okay, it doesn't matter which one I eliminate. But in the second step, when I eliminate the same variable from another two equations, it's got to be the same one. So if I look at kind of equation 1 and 2, I see that it would be pretty easy to eliminate the variable y. Okay, so let's just go with that. And I can just multiply this guy right here, equation 2, by negative 4. And what's going to happen is if I had a negative 4 here, I'd have a negative 4y and a positive 4y, so y would drop out. Okay, so I'm going to multiply equation 2 by negative 4. So negative 4 times negative 6 is 24, so it'd be 24x. Negative 4 times y is minus 4y. Negative 4 times 4z is minus 16z. And this equals negative 4 times negative 25 is 100. Okay, so this is equation 2. Again, I'm not going to label it because it's going to drop out in a minute, and we're going to have something different. Then let me write equation 1 underneath. So 2x plus 4y plus 5z equals 15. So again, now I want to add the two left sides, set this equal to the sum of the two right sides. And again, make sure the left side has all your variable terms. Make sure the right side has just a constant. Okay, that's how you want to set it up. So 24x plus 2x is 26x. Negative 4y plus 4y, that's going to go away, right? We can cancel that. Negative 16z plus 5z is going to give me negative 11z. And this equals 100 plus 15 is 115. So let's erase this. And let's drag this up. and we'll call this equation 4. And let me use the same color so it's consistent. So this is going to be equation 4. Okay, so now we want to eliminate the same variable, which was y, from two other equations. So I can't use 1 and 2 again. So I can use 1 and 3 or 2 and 3. So if I use 1 and 3, it's going to be a little bit more challenging than if I use 2 and 3, right? Because if I use 2, again, I have y with that coefficient of 1. It's a little bit easier to work with. So let's eliminate y from 2 and 3. So for equation 2, I'm just going to multiply it by positive 3, because if I had a 3 there and a negative 3 there, again, I could cancel the y. So if I multiply equation 2 by 3, I would have negative 18x. I would have plus 3y. I would have plus 12z. And this would equal negative 75. Okay, I just multiplied each term there by 3. Okay, that's all I did. Then what I want to do is take this guy right here, this equation 3, and write it underneath. So negative x, then minus 3y, then plus 3z, and this equals negative 16. Okay, let me scroll down and get some room, and I'll come back up. So what I want to do is add the two left sides, set this equal to the sum of the two right sides. So negative 18x minus x is negative 19x. We know that 3y minus 3y, that's going to cancel. We know that 12z plus 3z would be plus 15z. And this equals, for negative 75 minus 16, that's negative 91. Okay, so let's erase this. And let's drag this up. Okay, let's drag this up. And let me scroll back up here. So let me label this in the same color so we're consistent. So this is going to be equation 5. Okay, so now with equation 4 and 5, we have a linear system with two variables. Now this one is not as easy to solve with substitution. It's not really easy to solve with elimination either. We just have to kind of pick our poison. So let's just go ahead and use elimination for this one. I am going to choose to eliminate z. So the least common multiple between 11 and 15 would be the product of the two, which would be 165. Okay, so all I really need to do, they already have opposite signs. I'm just going to multiply equation 4 by 15, and I'm going to multiply equation 5 by 11. Okay, again, they have opposite signs already. So if we just do that, these guys are going to end up being negative 165z and positive 165z, and we can cancel them out. So I would start by multiplying equation 4 by 15. So 26x times 15 is 390x. Then minus. 11 times 15 is going to be 165. So this would be 165 and then z. And this equals 115 times 15 is 1,725. What we're going to do for equation 5 is we're going to multiply both sides by 11. Okay, so negative 19x times 11 is going to be negative, negative 209x. Then we have our plus. We know that 15 times 11 is 165, and then times our z. And this equals, we're going to have negative 91 times 11, which is negative 1001. Okay, let me scroll down and get some room going, and we'll come back up. So if we add the two left sides together, this is going to cancel. 390x minus 209x gives me 181x. And this would be equal to 1,725 minus 1,001 is going to be 724. Now, what I want to do to isolate my x there, I want to divide both sides by 181. And what I'm going to get is that x is equal to 4. Right? 724 divided by 181 is going to be 4. Okay, so at this point, we know x is 4. So let me erase this. Let's come back up here. And I'm just going to say that x is equal to 4. So we know that at this point. So I can plug in a 4 for x in either equation 4 or equation 5, and I can find out what z is. So let's just go ahead and use equation 5. So we would have negative 19 times, plug in a 4 for x, plus 15z equals negative 91. Okay, so let's scroll down a little bit. So negative 19 times 4 is negative 76. And then plus 15z equals negative 91. So what I'm going to do is I'm going to add 76 to both sides of the equation. So this will cancel, obviously. Let me scroll down a little bit more and get some room. Negative 91 plus 76 is going to be negative 15. So what we would have is 15z equals negative 15. So we know z is going to be negative 1, right? Divide both sides by 15. We get that z is equal to negative 1. Okay, so let me put z is equal to negative 1. All right, so we know x is 4. We know z is negative 1. We really can erase these two equations at this point because we don't need them anymore. Now all we need to do is figure out what y is. So y equals what? We'll just plug into either equation 1, 2, or 3, okay, and figure out what y is. So what I'm going to do is I'm going to plug a 4 in for x and a negative 1 in for z, and let's just use equation 2. So I'm going to do negative 6 times 4 plus y plus 4 times for z is a negative 1. This equals negative 25. Okay, so we know this would be negative 4, so let's just write that. And we know this would be negative 24, so let's write that. We also know that negative 24 minus 4 would be negative 28. So let's write y minus 28 like this. If we add 28 to both sides of the equation, we're going to find that y is equal to positive 3. So let's erase this, and let's put that y is 3. So let's erase this, and we found our answer. Again, as an ordered triple, it's the x value first, so 4, comma, the y value second, so 3, and then the z value is last, so negative 1. Again, it's x, comma, y, comma, z. Okay, and again, you can remember this because it's in alphabetical order. So the order triple is 4, comma, 3, comma, negative 1. Again, an x value of 4, a y value of 3, and a z value of negative 1. So one type of problem that you might encounter that is actually easier to solve but causes a lot of confusion for students is where you have a linear system in 3 variables, but one of your equation only has 2 variables, okay? So something like this where we have 4x minus z equals 3. You've got only x and z. And then the other 2 equations have x, y, and z. So the other ones, you have 6x minus 5y minus z equals negative 25. And you have x minus y minus 2z equals negative 7. So let's just go ahead and label these. This is going to be equation 1. This is going to be 2. And this is going to be 3. So what can we do here? A lot of students will struggle and say, I don't know how to get started. Well, really, a lot of the work has already been done for you. You have a linear equation in 2 variables only with equation 1. So what you can do is you can take equation 2 and 3. You can eliminate the variable that this one's missing, which is y, okay? And so you would have equation 1, and let's just call it equation 4. So those 2 would make up your linear system in 2 variables, and from there you can figure out everything else, okay? So it just kind of saves you a step. So what I'm going to do is I'm going to take 2 and 3, and I'm going to eliminate the variable y. So to do that, I would want this to be plus 5y, so it would cancel with this minus 5y. And I can do that by multiplying both sides of equation 3 by negative 5, okay? So if I multiply x by negative 5, I get negative 5x. If I multiply negative y by negative 5, I get plus 5y. If I multiply negative 2z by negative 5, I get plus 10z. And this equals, if I multiply negative 7 by negative 5, I get plus 35. So I've got this guy, and again, I've got this equation 2, which stays as is. 6x minus 5y minus z equals negative 25. Okay, so if we add the 2 left sides, set this equal to the sum of the right sides, what we're going to find is that this guy is going to cancel. And negative 5x plus 6x is going to be x. And then plus, you've got 10z minus z, which is going to be 9z. And this equals, you've got 35 minus 25, which is 10. Okay? So let me erase this real quick, and let's just label this as equation 4. Okay? So equation 1 and equation 4 give us a linear system in 2 variables. So let me just copy this one down here. Again, this is 4x minus z equals 3. In this case, it's easiest to use substitution because I've got a negative 1 as the coefficient of z in equation number 1, right? I drug this down here. This is equation 1. And in equation 4, I've got a 1 as the coefficient for x, okay? So whichever one you want to use, I'm just going to go with equation 4, solve it for x, plug it in for x in equation 1, okay? So let me recopy this number here so I don't get confused. All right, so let's scroll down. And what I'm going to do again is solve equation 4 for x. So I would have x is equal to, just subtract 9z away from each side, so negative 9z plus 10. And then the whole idea is I'm plugging this, again, what x is equal to, I'm plugging that in for x in this equation. So that's going to go in right there. Okay, that's all we're doing. So 4 times, again, plugging in for x, it's negative 9z plus 10. And then you have minus 1z, or just minus z, equals 3. So let's solve this real quick, find out what z is. We'll go back and figure out what x is. So 4 times negative 9z is minus 36z. Then 4 times 10 is 40, so plus 40. Then minus z, okay, and that kind of looks like a 2, so let me make that more clear. And this equals 3, okay? So we have negative 36z minus z, that's negative 37z. Let me get rid of that. And what I can do is I can subtract 40 away from each side of the equation. So that's going to be gone. 3 minus 40 is negative 37. So we can see that z is going to be positive 1, right? Because if I divide this side by negative 37 and this side by negative 37, we're going to get that z is equal to 1. Okay, so let me erase all this. I'll put a line and say that z is equal to 1. Now, with equation 4 or equation 1, we can plug back in and figure out what x is. So let me erase this from here. I don't even need it anymore. I'm just going to plug into equation 1, and I can just erase equation 4 because I'm not going to need that anymore either. So I'm going to plug a 1 in right here. Okay, so I'm going to have 4x minus 1 equals 3. If I add 1 to both sides of the equation, I get that 4x is equal to 4. Obviously, x there is going to be 1, right? If I drag this up and I divide both sides by 4, I get x equals 1. So z is 1 and so is x. Now, what is y? Well, I need to plug into either equation 2 or 3. Again, something with y involved. So let's just go ahead and plug into equation 3. It's a little bit easier. So x is 1, so I'd have 1 there. Then minus y, that's still unknown. Then minus 2 times z, z is 1, so I can just leave that as it is. And this equals negative 7. So 1 minus 2 is negative 1. So let's erase this and put this as a negative 1. And so let me add 1 to both sides of the equation. This goes away. Negative 7 plus 1 is negative 6. And to finish this off, let's divide both sides by negative 1. And we'll find that y is going to be equal to positive 6. So y is equal to 6. Again, as an ordered triple, you would have that x is 1. That's the first one. Y is 6. That's the second one. And z is 1. That's the third one. Again, it's going to be your x value, comma, your y value, comma, your z value. It's in alphabetical order, so it's very easy to remember. All right, so now let's move on and talk about the kind of special case scenarios we're going to see. So we're also going to have situations where we have no solution and situations where we have an infinite number of solutions. Again, it's the same scenario. So if you see your variables drop out and you get something that's always true, you have an infinite number of solutions. If you see your variables drop out and you have a false statement, then you know you have no solution. Okay, it's just that simple. So let's go ahead and look at this guy right here. So we have negative 3x minus 3y minus z equals 12. So let's say this is equation 1. We have 5x plus 2y plus 5z equals negative 3. This is equation 2. We have negative 6x minus 6y minus 2z equals negative 30. Let's say this is equation 3. Okay, so let's go ahead and eliminate from equation 1 and 2. Let's eliminate the variable z. Okay, it looks like it's pretty easy to do. So let's just multiply equation 1 by 5. So what I'd have is negative 3x times 5 is negative 15x. Then negative 3y times 5 is minus 15y. Then negative z times 5 is minus 5z. And this equals 12 times 5 is 60. Okay, and then I have equation 2. I'm going to leave that alone. So I'll have my 5x plus 2y plus 5z, and this equals negative 3. Okay, so let's add the left side, set this equal to the sum of the right sides. So negative 15x plus 5x is negative 10x. And then negative 15y plus 2y is minus 13y. And then negative 5z plus 5z, that's going to cancel. And this equals 60 minus 3, which is going to be 57. So let's call this equation 4. Okay, so far no problems, right? Everything's okay. So let's call this equation 4. Let me label this in green. And now let's eliminate z from equation 1 and 3, okay, because that's pretty easy to do. Equation 3 I'm going to leave alone. So I'm just going to leave that as negative 6x minus 6y minus 2z equals negative 30. And for equation 1, what I'm going to do, I need this to be plus 2z, so it would eliminate with this minus 2z here. Okay, so to do that, I'm going to multiply both sides of the equation by -2. So -2 times -3x is positive 6x. -2 times -3y is plus 6y. You can already see a problem. And then -2 times -z is going to be plus 2z. Okay, and this is going to be equal to -2 times 12 is going to be -24. Okay, you already see the problem because this whole left side is going to cancel. It's going to be gone, right? So -24 minus 30 is -54. So this is basically going to turn into 0 is equal to -54, okay, which is nonsense. So this is always false. So when you get something like this, just stop and say there's no solution, okay? So you can put the symbol for the null or empty set, or you can write out no solution. All right, let's wrap up the lesson and look at one more special case scenario. So suppose we have x plus 2y minus 2z equals 1. Again, I'm going to label this as equation 1. And then 5x minus 3y minus 2z equals 27. I'll label this as equation 2. And then -2x minus 4y plus 4z equals -2. I'll say this is equation 3. Okay, so let's just go through and eliminate our variable. Let's just go ahead and do x. Okay, so from equation 1 and equation 2, I can get rid of x pretty easily. I can multiply equation 1 by -5. Okay, so -5 times x is -5x. And then plus -5 times 2y would be -10y. So let's say minus 10y. And let me make that a little bit better. And then we would have -5 times -2z, which would be plus 10z. And this equals 1 times -5 is -5. Okay. And then I'm just going to copy equation 2. So 5x minus 3y minus 2z equals 27. Okay. So add the left sides, and the x variable is going to cancel, right? So this is basically gone. -10y minus 3y is going to be -13y. So -13y. 10z minus 2z is going to be 8z, so plus 8z. And this equals, you have -5 plus 27, which is 22. So this equals 22. And again, so far so good, right? No problems. Everything looks okay. So let's drag this up. So again, we used equation 1 and 2. So now let's use equation 1 and 3. And let's again eliminate the x variable. Okay, so to do that now, I'm going to multiply equation 1 by positive 2. So what I'm going to have is 2 times x, which is 2x, then plus 2 times 2y, which is 4y, then minus 2 times 2z, which is 4z, and this equals 2 times 1, which is 2. Okay, so this is a transformed version of equation 1. Again, we just multiplied it by 2. So then I want to take equation 3, which is -2x minus 4y plus 4z, and this is equal to -2. Now, do you see a problem? Yes, of course, because this is going to eliminate and this is going to eliminate. You're going to get 0 equals 0, which is always true. Okay, so when it's always true, when you end up with a true statement like this, you have infinitely many solutions. Okay, so let's just erase this and we can just list our answer. So let's just write this out and say we have infinitely many solutions.